final function that we need to be able to graph here is cotangent x, which on our formula page there says is the reciprocal of tan x, so it's 1 over the tan x function. And we can graph cotangent x pretty much the same way that we did our graph of the tan function. When we did our tan function, we said, okay, tan x is going to be equal to sine x over cos x. And we looked at where sine x and cos x were 0. So if cotangent is equal to 1 over sine tan x, or the inverse of it, it is going to be equal to cos x over sine x. So what we want to consider is what is going to happen when cos x equals 0. Well, if cos x is equal to 0, cotangent x is going to be equal to 0 as well. We've got 0 divided by whatever sine x is. Now, where does that cosine function equal 0? Well, it is 0 at x equals pi over 2, 3 pi over 2, etc., etc., etc. What's going to happen when sine x is equal to 0? Well, if sine x is equal to 0, we have cos x divided by sine x. We're going to be dividing by 0, so cotangent x is going to be undefined. So we're going to have a vertical asymptote for our graph at all the places where sine x is equal to 0. Well, where does sine x equal 0? At 0, pi, 2 pi, and so on and so on. So let's start putting this together to make our graph. Move this down a little bit. I'm going to put 2 pi, pi, pi over 2, 3 pi over 2, and of course I can do a negative pi over 2 as well. Let's start by putting on our vertical asymptotes. So our vertical asymptotes occur where sine x equals 0, at 0, pi, 2 pi, etc., etc. So 0 and pi, 2 pi, just like that. And then we're going to have our zeros wherever cos x is equal to 0, so at pi over 2, 3 pi over 2. So basically every interval, pi over 2, we are going to have a 0, or an x-intercept here. Now we just need to figure out where this function is positive and where it is negative. So the intervals of where it's positive and negative for cotangent x are going to be the same as they were for tan x. So we can just go back to our old cast rule here. C, A, S, T, and C. So if we start in this first interval here from negative pi over 2 to our first asymptote at 0, only cosine is positive, so tangent is going to be negative, so cotangent is going to be negative. So this curve has to approach the asymptote from, well, way down here like this. If we go to our next interval between 0 and pi over 2, all of these are positive, so our cotangent function is going to be positive as well, so it's got to be approaching this asymptote way up there. Our next interval from pi over 2 to pi, only the sine is positive, so tangent is negative, so cotangent is negative, so this has got to head off to infinity, negative infinity. So this interval, our curve, is going to look like this. Okay. If we go to the next interval, between pi and 3 pi over 2, tan is positive, and then from 3 pi over 2 to 2 pi, it is only cosine is positive, so it's negative. So again, we're going to have something that looks kind of like that. Similarly over here, we can sort of finish off what that's going to look like, kind of like that. So our cotangent curve is reasonably similar to our tangent curve, which is kind of to be expected. It's just sort of well, flipped over a little bit. So let's fill in the domain and the range, etc., etc. Our domain here is clearly going to be x is an element of all reals, such that x does not equal these places where we have these asymptotes. So it's going to be um, k times pi, where k equals 0, plus minus 1, plus minus 2, dot, dot, dot. Our range is all real numbers, because these tend off to infinity. Amplitude doesn't make really sense to talk about it, because it tends off to infinity. Our period, well, it's going to have a period of pi, just like the tan function did. And you can see that because the zeros repeat each interval of pi. We've got one at negative pi over 2, one at pi over 2, and so on and so on. Speaking of zeros, our zeros occur anywhere where we have well, at intervals of pi over 2. So we can say pi over 2 plus or minus, let's say plus k. Again, where k is equal to 0, plus minus 1, plus minus 2, etc., etc., etc. And our asymptotes, again, well, they're the same as these restrictions on our domain. So our asymptotes are going to occur at x equals k pi, where again we have this usual definition of what k is. And that's our final trig, reciprocal trig function that we have to be able to graph.